Okay, so suppose we want to have $150 a month invested for 5 years at 8% compounded monthly. Okay, so that would be a savings annuity. So we're going to use the PN equals D times 1 plus R over K to the NK minus 1 all over R over K. And we know the monthly payment is going to be $150, or the monthly deposit, 1 plus 0.08, 8% written as a decimal, over 12 because we're compounding monthly, and then 12 times 5, or we could rewrite that as 60 minus 1, and this is all over 0.08 over 12. So the amount of money that we're going to have after 5 years, and I noticed that I forgot I didn't put the parenthesis around this bit of stuff because it's the payment times that whole chunk. So when you do enter that, it ends up that we're going to have $11,021.53. And so now what's really going to happen, because we're going to, after those 5 years, we're just going to leave the money. So it's like turning into a kind of that lump sum deposit, and we're not making any more deposits and leaving it for 21 years. So it's really a compounding interest problem now. So we're going to take that $11,021.53 and multiply it times 1 plus 0.08 over 12, and it's going to do this compounding every month for 21 years. So we're going to write 12 times 21, or you could multiply that just to write it a little bit simpler, and that will be 252. And so we enter that into our calculator, we're going to get $58,807.85. So again, what I'm saying is that we had, this is a savings annuity, that's our first part, and then it turns into just regular compounding interest because we're not depositing monthly payments anymore. And so what it wants us to do is compare that situation with supposing that we don't invest anything at all for the first 5 years, and instead what we're going to do is deposit $150 every month for 21 years and kind of compare. And so let's see what's going to happen. So we're back to talking about that savings annuity. So we're going to say that our monthly payment is that $150 times 1 plus 0.08 over 12. And that's going to be to the 12 times 21. So again, I'll simplify that to be 252 minus 1 all over 0.08 over 12. And so when we plug that in, we're going to have $97,553.81. So at first glance, this looks like less money overall than what we have here. But just kind of something to keep in mind is that the first one, we only made payments for 5 years. And so we took $150 every month for 5 years. And when we do that, that 150 times 12 times 5 is $9,000. So we deposited only $9,000 and then we'll let it sit there and earn money, and it made its way up to $58,000. Now what's happening with this other situation is it was $150 every month for 21 years. And so instead, when we deposit that, again, 150 times 12 times 21, we're putting in $37,800. We're putting in a lot more money. And so if you look at the interest, and again, this is more than what the problem asked, but just kind of seeing something interesting, the actual answers it wanted for this second part is here, and for the first part is here. But it's just kind of interesting to see the difference in what you're actually inputting and getting back out. And so you can see that when you invest earlier, even if you stop making those payments, you're still going to make a good chunk of money, and that's the power of compound interest.